Yeah, so welcome to this week's episode of the Forestry Tomorrow podcast. And we are at episode number 7.
I'm looking forward to when we don't have to mention the episodes. You know, it's like episode number 5,327. So
yeah, but that's also awesome when we get to that number, just to say it out loud.
Yeah.
Yeah, so we're getting close to episode 10.
Yeah.
That was sort of the aim for, having everything locked down.
That's one of the milestones, yeah.
What do you think about the learning curve? Are we...
I think it's hard for us to judge.
Yeah, you're right.
But I feel like the English
is
getting
steep
better.
enough? Or is it...
Probably not.
Okay. Yeah, let's see.
We're getting
At least we have talked with a few who's actually listened to it.
Really nice. Thank you.
Yeah, and I hope they're being honest with us.
Yeah.
Every time I hear someone say something nice about it, I'm like, are you lying to me?
Yeah, exactly. I agree.
Yeah, but anyway, we'll continue because it's fun and hopefully it adds value.
At least we like it ourselves, so doing it.
Good. So last time it was not last time. It was a couple of episodes ago. We talked about remote-controlled machinery for forestry. Yeah. I think the conclusion was that, there'll be autonomous machines in a bit.
Yeah.
So.
It was more, and we talked about this. The feedback from just being in the machine. Could you live without that? You know how it is tumbling around. So
Yeah. But it seems like there's still innovation going on. We just talked to Frederik Linde from Forest Omni, and he told us about this company called Kodama.
How's it spelled?
It's Kodama, and it's it's an American company.
Yeah.
So I don't know. Kodama.
Kodama.
Anyway, so they just unveiled a machine teleoperation platform. And it's actually quite new. It was unveiled. I'm not exactly sure when it was unveiled, but this article that I have here from forestnet.com is from the 8th of October.
This year,
yeah.
Okay. So that's...
So it says, product introduced for pilot to tackle labor shortages and reduce operational costs for loggers. So Kodama Systems, which is an innovator, that's what the article says, is an innovator in forest management and wildfire mitigation technology, has announced the launch of its cutting-edge machine teleoperation platform, Kodama Autopilot.
Autopilot. Okay.
Yeah. Auto. So it was actually demonstrated, and the machine operator controlled a log skidder from 100 miles away via satellite. And some
Starlink
it doesn't say anything about that, but that was actually sort of what the conclusion. When we previously went through this, that the distance, mainly due to the need for communication between the operator and the machine, was not long enough or far away enough to it actually make sense.
Yeah.
So here it's hundreds of miles away.
Hundreds
of miles.
Okay.
So that makes sense.
Yeah. Now you're...
Yeah. So it's a strategic collaboration between Kodama and then Wheeler Forestry. So I'll just read out a what's
section.
It called?
Citation.
I don't know.
No, it's...
Anyway, Merritt Jenkins, CEO of Kodama, says, Wheeler Forestry collaboration has empowered us to bring game-changing product to the industry. Autopilot eliminates long commutes, improves operator safety, and reduces physical strain by enabling machines to be controlled off-site.
Yeah.
We have been working with the logging community to develop this product over the past 2 years.
Yeah.
And we are thrilled to demonstrate our system on a national stage. And it's available for pilots in 25, so next year. Mm-hmm. So Autopilot enables business owners to run double work shifts.
Yeah.
And opens new employment opportunities for the next generation of loggers.
Mm.
And then it actually states here in the sort of final stage here at Kodama plans to also introduce autonomous capabilities later in the year.
Yeah, you could say that when you can remote control something, it's just a matter of who gives you the input to do something. Is it a human or something else? So,
yeah,
at least they've solved one of the hurdles. But is it on any machine, or is it very specific machines?
I think it's on this specific machine.
Okay.
As far as I know.
They probably had to retrofit some machine.
Yeah. But it's quite awesome. If you go and look at the page, there's this guy sitting with a Xbox controller,
like playing a video game.
Yeah, and it really looks awesome.
Yeah, it's going to be fun to follow if this is the future of it. Then you could also. It could be just a kid, controlling it. Kids are much better at games than adults anyway, so...
Yeah, you're right. So it actually has cameras that enable operators to directly control the machine. It has computers, state-of-the-art video compression, and advanced autonomous navigation algorithms. It has satellite connectivity. Yeah. And of course GPS and LiDAR to detect obstacles.
Cool.
So some of the ingredients is close to an autonomous machine, right?
Yeah, exactly. That's also a kind of a strategy you can have, is also, make autonomy a journey, not something you implement right away, because now they can get a lot of data to train, models, AI models on.
Yeah.
So it's a step towards full automation. It's also what has been done in the automotive industry again.
Yeah.
Tesla has recorded a lot of data before they even began to think about autopiloting.
Yeah. And if someone hears this and has tried this,
that'd be
by all means, write us.
Yeah. Also, given the conclusion last time, is it possible without the feedback being in the machine?
Yeah.
So it'd be nice to see.
I don't know, because an Xbox controller also is capable of vibrating.
Yeah, you're right. I don't know if that's enough.
Added that feature also. Probably not. But anyway, enough about Kodama, I think.
Yeah. I also just typically we introduced the
extended feature.
The extended feature.
The long one.
Yeah, the long one. So maybe we should do that now.
Yeah, feel free to do that while I drink coffee.
Yeah, because last time we talked about we should probably jump out of the rabbit hole again with all the robots, and so we decided that this.
I find a new rabbit hole.
Yeah, this week's podcast should be about sensors in general. Yeah, and of course the application.
And I have a sensor
forestry.
that is a new rabbit hole.
One type that's a new rabbit hole. Nice.
Yeah, technology. Yeah.
Yeah, but you also mentioned a lot of sensors on this machine, which is of course.
Mm-hmm.
Yeah. So. Yeah, that's the
extended feature.
Yeah.
I have one more small news.
You know a little about mine, so you decide if you want it.
Oh, you
okay.
You go with
because
yours.
I had problems finding a good one for this episode. They did something else. So I went to my favorite new friend, ChatGPT, and of course just asked it, and I read it. Can you give me a fun fact or a small story for our podcast Forestry Tomorrow? And it answers, certainly, here's a fun fact and story you can share on Forestry Tomorrow. Did you know about the Wood Wide Web? Ta-dum.
Yeah, then I'm supposed to laugh now.
Yeah. Why?
No.
I didn't either.
Tell me.
So, deep beneath our feet, forests have their own underground internet. Trees are connected through a vast network of fungi known as mycorrhizal cohesive networks. These fungi form a symbiotic relationship with tree roots, allowing them to exchange nutrients, water, and even chemical signals. Through this network, trees can talk to each other, with citation marks, warn of potential dangers like insect infestations, and even share resources with neighboring trees that are struggling. And then there's some more text, and I, of course, asked, okay, is this real? And ChatGPT said, yes, it's real. The concept of the Wood Wide Web is based on scientific research into mycorrhizal networks, which connect trees through underground fungal networks. So it sounds amazing, right?
Yeah.
Do you believe it? I haven't fact-checked this. I might just add.
If the internet says it's real.
Yeah, as Abraham Lincoln said, you shouldn't believe everything you read on the internet.
Yeah.
So yeah, it's and it can signal dangers, and there's something called mother trees.
Okay, so for next week's episode, you'll do a fact check on that.
Oh, I think I will watch the movie. What's it called? With the Navi. So probably. But that's about how the entire planet is connected through the trees' roots.
Okay.
It's probably based on something like that. The story is probably more based on Native America, but yeah. What is it called? Pandora is the planet, but I don't think that's the name of the movie. It was the first in the new wave of 3D movies. Was it the first one? Filmed with 2 cameras at the same time.
Ah, okay, awesome.
Yeah. Let me just 1 second.
Okay, then I can continue with the next one. So this is actually not news, but I was searching the internet for funny ways to use wood, and the autocomplete function in Google stated something about cheese. And then I was like, what? So I bring to you the Cheesegate.
Okay, this is going
there's
to
nothing.
be
There's nothing called the Cheesegate, but
okay,
it's just
cool.
me.
Yeah.
So anyway, I think it's actually a sort of big scandal that ran. I think it was in 16 or 17. Apparently, a lot of cellulose has been added to Parmesan cheese in these,
these graded cans things.
Yeah, exactly. So it's not actually the usage of cellulose in food that's not the problem, because it's actually allowed up to 4%. But it's the mislabeling that's the issue.
Yeah, okay.
So it's used in cheese in order to have it more easily come out of the...
so it doesn't lump together.
Exactly.
Yeah.
Exactly.
Like when you put rice in your salt.
Yeah.
Yeah.
Exactly. So, and again, I mean, cellulose in foods are quite common. But there's actually been a lot of fines related to this matter. Walmart and... what's it called? We know the Kraft, the manufacturer
Of what?
Just a second. I'll show you.
But for me, there's just buy the real cheese, please.
This company.
Oh yeah.
Kraft
one of these
Kraft Foods.
Yeah, really big manufacturers of food.
Yeah. So there's a lady in the article that says it's actually so using cellulose actually grew in popularity in the 70s.
Okay, is it because it was just?
It was because people got more interested in fiber in food.
Oh.
So instead of applying whole wheat, then they turned
to
towards
the trees.
towards whole wood.
Okay.
So she sort of finalized this. So, but the real issue with companies utilizing fillers like cellulose, says Hanson, is that it's unfair for consumers to have to pay cheese prices of what in essence is sawdust.
It sounds so nasty.
It's really a kind of consumer fraud. But sawdust costs an awful lot less than cheese.
Just thinking about, that horrible Parmesan cheese, it actually tastes like sawdust. So don't buy it.
Yeah,
Buy the real thing.
exactly.
But
And also Parmesan is quite expensive.
Yeah, but that's also aged for at least 2 years.
Yeah.
It's because it actually takes an effort to create, and you can taste the difference. So, by all means, people, buy the real product. You don't want to live off sawdust.
No. And you're the company's nutrition expert, or at least the most most food happy one of us.
Nutrition expert. I like to make food.
Yeah, and you're quite good at it actually.
Yeah.
That's
Maybe I should include some sawdust in. And actually, I don't know. You have also seen probably some of these survivors. You put people on an island and have them survive for as many days as possible.
Yeah.
They have the American version of. I can't remember what it's called. Probably, it's where they live alone.
I think you would be good at that.
Probably not.
You can eat everything.
Yeah,
and cook everything.
But the idea was that one of the persons there who couldn't find food, he began to eat the bark of the trees. And he survived for that for some days, but it completely destroys your stomach.
Yeah, I could imagine.
Yeah, so you get a lot of fibers, but if you only get fibers...
Yeah, but that's like 100% fibers.
Yeah, it's hard to get out of your body again. So
that's also what it says, because the fibers, from wood, doesn't have anything that will actually benefit you in terms of nutrition.
Yeah, that's also here
compared to wheat.
Yeah, okay.
So don't eat the forest.
No.
Anyway, that was Cheesegate.
Nice. I think that was really fun.
Yeah,
not fun, but
it was eye-opening.
Yeah, exactly.
Yeah.
Okay.
The extended feature.
Yeah, let's get to it.
Yeah. So I found a quite substantial sort of page. Well, the overall theme of this is sensors for digital transformation in smart forestry.
Yeah.
Yeah. And it talks a lot about what smart forestry is, and I think to no surprise, it covers and includes a lot of sensors in various ways in order to, also what we talked about in previous episodes, in order to know as much as possible in terms of, the stand, the environment, all kind of elements that will actually benefit you in the management part of
the
forest.
decision making.
Yeah.
Get information, yeah.
Exactly. So they have a quite nice list here with sensor types, and I'll just quickly go through them, and then we could we'll probably not deep dive into them, but I think we'll touch upon each of them.
Yeah, and we can always deep dive in another episode on some of them.
Yeah. Because so I'll get to my new rabbit hole in a bit. So some of the sensor types sounds sort of obvious, but nonetheless, it's a sensor. So one is GPS, GNSS,
That makes sense, right?
Yeah. Then we have temperature sensors, moisture and humidity sensors, soil pH sensors, RGB cameras.
Okay.
Thermal imaging cameras.
Yeah. Okay.
And then probably the word we have mentioned the most time in this podcast.
Yeah.
LiDAR.
Yeah. Yeah.
And then multispectral cameras.
Yeah.
So if we start from the top, GNS, GPS, Wi-Fi, etc., what's that used for?
Yeah, at least GPS and so on. Of course, it would be nice to have a geolocation of whatever you're measuring. So
yeah.
Especially, well, kind of always, but especially in the forest, right? And Wi-Fi, I'm a bit... Why you need that?
I don't know why that's listed here. But
at least, Wi-Fi you can use to transport data. But I don't really know why it's mentioned here.
You could probably localize on Wi-Fi also.
Yeah, you can, but that's...
You could also see the guy.
It's just that to localize in that way, you use triangulation, and I don't really know. And if just use GPS out there, I think, because it's better covered. So what your phone, there's also GPS in your phone. You can localize you. And if you are in the city, for example, also a city like New York, where it can be hard to get down through all the buildings from the GPS point of view, there you can use the mobile, what's it called, antennas and so on, to also help triangulate. So you can do a lot of stuff if you combine them. But
yeah, moving on.
But generally speaking, it's to locate you.
Yes,
somewhere.
Exactly.
Yeah.
And then the next one, temperature sensors.
That's probably the cheapest sensor in the world because it's mass produced. It's extremely simple.
Yeah.
If you have ever heard PT100, which you have worked with electronics, you've heard that 1,000 times. So, like if you build a device, putting in a temperature sensor in it won't cost you anything. So,
yeah, exactly.
And the temperature is pretty nice to know in many occasions.
Yeah.
So it makes sense to throw in there because it doesn't cost anything. I don't know,
but actually, I never come across someone using temperature sensors.
Like a forestry setting.
Yeah,
we haven't heard about it, have we?
Although, for instance, with what's that called, like fruits. There's of course the risk of having minus degrees.
Before you halved and these things.
In the early spring, that could actually damage the, I don't know the right sort of way to describe it, but it will
damage the crop, which is fruit in this case.
Exactly.
But again, you can't really control that temperature.
I know some they try to cover it and prevent it from being that exposed.
In winemaking, you also actively use those first days of this. There's something at least in Germany called Eiswein, which is when you harvest after they have gotten the first frost.
Yeah.
So okay. In that sense, maybe we haven't heard about it in forestry. Anyone mentioning they measure temperature, right?
No. But if someone does, let us know.
Yeah.
Okay, moisture and humidity sensors.
Yeah. We talked the last time about where I had this small story about these vaporizing the leaves. So at least there you could imagine that they probably in that experiment they need somehow to measure that. So they're probably using it there. But would it also make sense in a more general setting?
I think it tells a lot about the actual sort of climate. And in some areas, you would like to have you could also, sort of design your forest to be at a certain climate. That's why you use, I don't know the English word, but skovbryn. That's to make sure that you have let's say, a more intact climate within. So that's one application. And there's also here, it says to determine trafficability of forest roads. I don't know.
Yeah, so now I think that we also need to split this in two. One is measuring like the humidity and so on of the surrounding air and so on, and another thing is of course of the soil. And it's clear if it's if all the tracks are on the water, you shouldn't drive in there with a big truck. But again, not an expert, but don't trees put their roots quite deep into the soil? So you need to actually be in a moist.
Depends.
Yeah. Some of course go deeper than others. So,
okay, then we have soil pH.
Yeah, and there our employee Benjamin, who did his bachelor on soil in forestry, knows a lot more than us, so he should probably be here to help us.
When we deep dive on this, he will be included.
Yeah, but at least as I remember when he told us about his studies, is that trying to control actually the pH value is is important because you need nutrition in the ground, and if you have low nutrition, it has some pH value, and then you add it was ashes they added, right?
Yeah.
To try to reach the right
to bring
value.
back some of the nutrition.
Yeah, and reach the correct level. So that makes sense.
Yeah. Then RGB cameras.
Yeah, that's cameras are on all the drones used out there. You go around with them, you take pictures. So it's quite obvious. You can visualize whatever's going on.
Yeah. It says wildlife monitoring, understanding forest, road conditions, navigational aid, all that kind of stuff.
Yeah.
Then thermal imaging cameras.
Again, please, if someone has done this in the forest, why is a good question, I think. To measure the temperature of the stem, or?
I think you could actually use it for so it says here thermal imaging is a similar technology that can be utilized in a broad field of applications for forest industry. It ranges from space-based imaging technologies that can be utilized to understand the temperature buffer capabilities of the forest, all the way to forest fire detection.
Yeah, okay, that of course makes sense.
Yeah.
Fire detection. And
it's rapidly discovered in this regard.
Yeah.
Right?
That's at least going to be much more warm than
Where
the rest.
The thermal imaging can be a fast way to locate and observe fire events. And then it says, these use cases have relatively straightforward use of thermal imaging, but it can also be used in phenotyping of forest. Do you know what phenotyping of forest is?
No, not at all.
Yeah.
So please,
just a second, because
educate me.
Yeah, I'll educate you when I also educate myself here.
Cool.
But the phenotyping method deployed here can be used to identify superior and inferior genotypes and estimate a productivity index for individual sites. The approach can improve blah, blah, blah. Oh, there was a better definition somewhere. I'll get back to this.
Yeah, that's okay.
Continue. But then if I go back to this list again, there was a mention that caught my attention, because it also says SAR. That's our new rabbit hole, I think.
The thermal cameras?
No.
SAR. Is that a sensor, or is it a...
So SAR is... Let me explain it.
Okay.
Synthetic aperture radar.
Synthetic aperture radar.
Yeah.
So some sort of radar.
Yeah, on satellites.
Okay.
So they use three, I think. I just briefly sort of read up on it. So it used three different, what's it called? Wavelengths.
Okay.
And of course, these have different. So they penetrate differently.
Yeah.
So some will be reflected on the forest canopy cover.
Mm-hmm.
Some will sort of go in the middle, and some of it will go all the way to the ground.
Yeah. Okay.
And by this, you're able to, for instance, detect deforestation.
Yeah.
It's awesome.
Right? Yeah. I guess you could use just a normal camera for that as well.
Yeah, but you can't do it on scale.
The normal cameras on a satellite, that's not good enough for detecting.
If there's a cloud cover.
Yeah, you're right. Oh yeah, this can of course go through the clouds.
Exactly.
Yeah.
We need to do a deep dive. That is
it's
really nice. Exciting.
I like to look at them. How do you translate it into a human vision somehow? So yeah, cool. Let's get back to that one.
Yeah, and then of course we have LiDAR sensors.
Yeah, And we've talked about that before. LiDAR is for measuring distance to something. And if you have a lot of them, you can measure a lot of distances and then create a point cloud, which creates a...
Yeah, and it's become a cheaper technology than previously.
Yeah.
Right?
Yeah. So, okay. Yeah, that also makes sense. Again, you mentioned this Kodama thing that had a LiDAR on it, again, to detect obstacles and so on. So, yeah. At least for when we get into measuring canopy height or as well as these radars. Yeah.
And then we have multispectral cameras.
Yeah, and I found those interesting from a forest management point of view. How much information can you get from the trees from these different spectras of that? I don't know much about it. We know that there is this near infrared, which gives us some other information than the classical spectrum we can see ourselves. Especially for, you can with that quite easily identify if it's as far as I remember, if it's needle or foliage.
I think you could go all the way down to species level.
Okay, cool.
And all depending on at what they also use it for agriculture here in Denmark.
Yeah,
you can detect what kind of
crops you have based on that. Okay,
based on where you are in the calendar and all kinds of stuff.
Yeah, and they are also mounted on satellites, just as normal cameras and so on, and LiDARs. Probably not LiDARs. Oh. Okay, cool.
Yeah. And then, of course, there's a lot of platforms involved in...
how to get the sensors out there.
Exactly.
Yeah.
So satellites, we've mentioned quite a bit.
Yeah, and one of the nice things about those are they're up there all the time.
Yep.
You don't need any operations. You don't need any people, anything. You just get information.
The only bad thing about satellites is that it's pretty far away.
There's a great distance.
Yeah.
But I guess the sensory equipment on satellites are also getting better and better and better.
Yeah.
So, of course, being 1,000 kilometers away from the surface is different than being 100 meters from the surface. So, yeah.
It sure is.
Yeah. But they're always there.
Yeah.
So, straight off.
Then drones.
Yeah, makes sense. You can fly over a large area.
Yeah.
Much closer to it.
Yeah.
And with a payload that could be one of these, several of these sensors at the same time.
Yeah.
Yeah.
And of course, range is smaller.
Yeah, exactly. You're much closer to the canopy.
Yeah, and then there's, for instance, unmanned ground vehicles.
So a little like
what was the...
We talked about Spot.
Spot, exactly.
Running around in the
that
forest.
was last episode.
Yeah.
I don't know how common that is. It's mentioned here, but...
no, I don't think it is. Not in the forest.
But then the last one that is mentioned, and that's... It seems like a no-brainer in terms of carrying around equipment that could actually collect data on the forest, and that's of course existing forest machinery because it's out there.
Yeah, and the machines in themselves are quite expensive. So putting on a sensor that could be expensive or not, it's probably not that big of a deal on a really big and expensive machine. However, there's probably something about when you need the information, because you want some information before the machine is there, and you can't get that if the sensors are on the machine. But if they are there, you could collect data that you can then use onwards.
Also, I mean, when the machine is driving around, there, it could be, it's capable of, it could be capable of measuring trees real time. Not only in the area that is, or not only in the sort of stand that is actually, let's say, filling. Could also be surrounding stands.
Yeah, there's of course some limit on how far you can penetrate into these things, into the neighboring stands. But yeah, it could do something like that. But I don't. The issue is probably not measuring, but the issue is you get if you have like a 3D lidar and some cameras, you get shitload of data.
Mm-hmm.
And who will process that data?
Who doesn't like shitloads of data?
Well, if no one uses it, then it's just.
We also know that.
Yeah.
I mean, we've collected a lot of data throughout the years.
Yeah.
And it's you get happy when you collect a lot of data because you know you could use it for something.
Yeah.
You know it has value, but it's not easy to collect data if you don't know why you're collecting it.
No. This idea of just collecting everything is that then you will just end up with a database filled with everything. And is that good? I don't know. And again, if these,
I mean, we have changed strategy.
Yeah.
On this.
Yeah, exactly. And the data we are collecting, it's not it's not a big load. Whereas imagery, high quality imagery, laser 3D point clouds. Now you're talking gigabytes of data, and
just the camera data for the podcast is a lot of data.
Yeah, and now if you want to take that data and what you are actually never asking for data. Mm-hmm. You're asking for insights. Mm-hmm. So how do I get from data to insights? And what are the insights, as you mentioned, that I actually want? What is interesting for me? And if that is, let's just say, okay, I would just like to know what is the diameter of just the trees near.
You just need to bring in your new best friend.
Yeah, maybe just have the guy who is out there in the machine just call you and say, I think they're like...
No, you just throw it into some AI and it will summarize it.
Yeah, ChatGPT.
Mm-hmm.
It can do everything.
Yeah, no, continue.
No, but yeah, that's the question, right? You need insights, and how do you take all of the data from these sources and get them to be something you can use for your management or whatever?
Yeah,
data collection is not a problem.
No, but actually, maybe the answer for that is actually machine learning and AI.
Yeah, it is. Of a lot of it is, and probably why machine learning and AI has become so popular is also now we have the computing power to somehow create these models that can do something about all the data, that we can actually ask a question into this and say, I would like to know this based on all of this data. Can you somehow with all the fancy algorithms figure that out for me?
Mm.
So yeah.
So now we need to start collecting a lot of data again.
Everyone collect data. Yeah, it's I was at a conference once ICRA in Singapore, which is a huge automation and robotics conference, mm-hmm. and there one of the keynotes was just collect all the data you can get, everything.
Yeah,
because then you're figuring out insights afterwards.
Yeah. At what point in time were we at?
Is that 2017?
Yeah, that seems like
so that's like 7 years ago. Yeah. Damn it, I'm getting old.
That's the statement you would use at that point in time.
Yeah, it was. That was also where big data was still a big thing. Yeah. So a lot of these fancy words means almost the same, but they just change the wording. So just be aware of that. The hype train.
Exactly. So that was actually the sensors covered here. I don't know if you have any sensors that we sort of missed. Some obvious ones.
Well, a lot of these are for, camera can do a lot of stuff.
Yeah, so a lot of these are single-purpose sensors. Or not single-purpose, but, of course, the funny thing is when you combine some of these into let's say a new application that's capable of combining sensor types and coming up with interesting findings.
I also think that probably something we should dig a bit more into is that there's been a lot of focus on climate the past years, which is of course for a reason there's that. But these the years we're going into, and also near future, there are much more focus on biodiversity as well as does that how is biodiversity affected also in the forests and so on. So it's of course be nice to somehow, how can we
environmental DNA.
Yeah, that's one of them, eDNA. But how can we measure biodiversity? And more importantly, from my point of view, how can we create models of something that's more tangible of measuring down to how does it affect biodiversity?
I thought you were going to say modify
biodiversity. Yeah, you want some, but no. There's at least a Danish company called Fauna Photonics who measure biodiversity.
Mm-hmm.
They measure insects with sound. I think they use the sound of the wings and stuff like that to measure it. So that's also be nice because that's a completely different technology. And this eDNA, as you mentioned, I know from a project we're in with a research project with some biologists that what they do is they have these traps, where they trap insects, whatever.
Yeah.
Then they take that and put all the small gritty things into a blender and then press play. And then that paste you get out of that, you put that into a machine, and that machine can tell you exactly what was the species that was in here.
Yeah.
It can't tell you how many there was of each.
There was actually, just a second. Where is she? Yeah, so Fanny Møller, they were on a conference. I can't remember which one it was, but she actually wrote a post afterwards that was quite interesting. See if I can find it. When were we? 26th of September. Here it is, I think. Yeah, so it's so there was I think it was a professor that told them that DNA sequencer English
Sequestrating, I can.
Yeah. Two-winged animal, if that makes sense.
Two-winged animals.
Yeah. All the way down to €1.
I don't understand. Down to €1.
Yeah, the price of it.
Oh, okay. So it's not that. It's not an expensive technology.
No, apparently not.
Yeah. Okay. Yeah. The thing is here, you need to again. At least what I've heard, there's still a lot of manual process in this. From what these Fauna Photonics does is you just put a sensor out there, and it can measure in some smaller area.
Yeah.
But here you need to collect somehow. That could be with a net things fly into, or these ground traps they walk into and stuff like that.
Yeah.
So okay.
Yeah. So no one. Fauna Photonics, no animal are harmed.
Yeah, they can write that on there. That's a good one. Yeah.
Yeah. Okay, but yeah. Should we?
Yeah, probably should wrap it up and then take some deep dives on some of these sensors.
Yeah.
Yeah.
The SAR.
Yeah, one of them. But also just look at how just satellite imagery changed the entire probably forest industry and a lot of industries just being able to get somewhat high resolution imagery from above.
Yeah,
you can get afar with not that much technology. That's okay, satellites are technology, but you get a lot from something simpler.
Actually, I think there's a lot of technology involved in satellites.
Yeah, that's a lot. It's not a nice environment out there either.
No. Anyway, let's wrap it up. And then do a deep dive.
Yeah, let's do that
on next episode.
Yeah,
but that's it.
Yeah,
take care.
Yeah,
Bye bye.